Hey y'all, this is a lesson on solving linear equations. I have several different types of linear equations in here. One step, multiple step, variables on both sides. So lots of stuff is going to be covered in this lesson. What's going to be useful when we're solving linear equations is the idea of an inverse. So inverses are helpful when we solve for a variable because an inverse means basically the opposite. Remember, a variable is just a letter. Fancy name for a letter. We can look at a couple examples of inverses. There's two types of inverses. We have additive inverse and multiplicative inverse. So we're looking for the opposite using addition and the opposite using multiplication. So if we're thinking about an opposite when we talk about addition, we're looking for its symmetric opposite maybe on a number line. So if we had a number line and we have -2, its symmetric opposite would be +2. And then the additive inverse of +3 would be -3. Now if we're talking about multiplicative, that means multiplication, opposite, then the opposite of a +2 when you're multiplying is going to be its reciprocal. You're going to flip-flop that. So we don't actually have to change the sign, we just have to flip-flop it. And what happens here is when you multiply inverses, you end up with 1, which is the identity, multiplicative identity. When you add inverses, you end up with 0, which is the additive identity. And these inverses and identities are going to help us solve. They're going to help us isolate variables. So the multiplicative inverse of 1/3, we're going to flip that, is 3/1, or just 3. So when we multiply those, we end up with the multiplicative identity. And that's our goal. That's where we're going. In summary, inverses help us undo operations to isolate a variable. So in this first example here, this is my variable and I'm wanting to isolate it, which means that I need to get rid of this 4, +4. What is the additive inverse of +4? That will be -4. I need somewhere to put that. And what I'm trying to do is I'm trying to move it away from x. So this equal sign creates a boundary for us. I'm going to put that on the other side of the boundary to keep it balanced. X is still just x. 4 minus 4 is 0. We have our equal sign. 10 minus 4 is 6. And you can check yourself. Our equation was this. We found x to be 6. Is 6 plus 4 10? Yes. Okay, number 2. We're trying to isolate x, so we need to move -5 away. Here's my boundary. I'm going to use the additive inverse so that they create the identity, which is 0. Bring down x, simplify, done. I have -4x equals 20. This is -4 times x. So since we're talking about multiplication, I'm going to need the multiplicative inverse. That's a negative right there. I did negative because this is negative. All right, so I use the fraction form. I use the multiplicative inverse. But if you want to instead of writing out the fraction, this is what I'm used to. I just divide both sides. -4 divided by -4 is 1, which is that multiplicative identity. 20 divided by -4 is -5. So that's where that came from. This is the technically correct way to do it. But essentially what you're doing, when you have division, division is multiplication of fractions. So you can kind of use them interchangeably if you want. But just know that when you're doing this, it's actually that. Either way is fine. I'm happy with either one. I'm more inclined to use this because it is less messy, but either one is fine. Okay, number 4. You'll see that I have it written 2 ways. When you see x over 5, that is the same as 1/5 x. How can that be the same? What is the number in front of this x? It's a 1. So all this is doing is pulling the 1/5 out front. They are both the same. It does not matter. It's just perspective, how you want to look at it. I'm going to show you both ways. They're really the same. This says x divided by 5. The opposite of division is multiplication. So we get x equals 10. Let's say it had been written this way. The multiplicative inverse of 1/5 is 5. So we still get 10. Really doesn't matter. They're both the same. Either one is fine. I am probably more inclined to write it this way because that's how I was taught. And I think it's a little bit cleaner. But this is also correct. They're the same thing. So that's one step, solving. Here's multiple steps solving. You can kind of think of this like PEMDAS backwards. So we're undoing PEMDAS. That's not like a rule or anything. It's just something that I've observed. You're starting with addition, subtraction. You're ending with multiplication, division. Not always, just usually that's what's happening. And here's an example of that. Our goal is to isolate x. To isolate x, we need to deal with this first. So I'm going to subtract it on both sides. And then bring down what's left over. And then last step, divide by 2 or multiply by 1/2. Either way is correct, and we get 2. You can check your solution just to see if it makes sense, and it does. Ooh, this one's cool. This is like saying, if you wanted to rewrite this, this is like saying that. So if it were to be like that, to get rid of the 1/3, we could multiply by 3, which is what we're going to do over here. We are going to multiply by what's in the denominator to clear that fraction. And we're going to write what we're left with and solve. Super simple. And then you can check your solution if you want. Is 15 plus 9 divided by 3 equal to 8? Yes. Yay, we did it. Okay. Ooh, that's cool. I love these. These are fun. We're trying to isolate this, which means we have to move positive 10 over the boundary. And then simplify. This makes 0. And then at this point, you can view this, if you wanted to, you could rewrite the negative x over 5 using a fraction. And to simplify that, you would multiply by the reciprocal. So that's essentially what we're going to do over here. We're going to multiply by whatever's in the denominator, and we're going to take that negative with it. So we're getting rid of the negative also. It is 65. And then you could plug in 65, check to make sure. Negative 65 over 5 is negative 13, plus 10 is negative 3, so my solution is correct. You could have done, at this point, we had negative x over 5 equals negative 13. You could have multiplied by just 5 and then divide by negative as your last step, and you'll get the same answer. So you can see here, this is one of the reasons why I really love mathematics. There's 3 different ways to see the same problem, and all of those ways are correct. So it's neat because whatever method you were most comfortable with, you can do and still get the same answer. Isn't math so neat? Okay, ooh, I love this. All right, we have this 2 out front. There's 2 ways we can solve this problem. One way is to go ahead and distribute and then solve. Another way is to get rid of the 2 at the beginning and solve. Let's do this left side first. I'm isolating x and then dividing as my last step, or multiply by 1/2. And then on this side, I'm isolating x, 0, and I get 15. Isn't that so neat? I think this way is a little bit faster. You have to deal with smaller numbers, but you get 15 either way. So there you go. Last page. This is solving with a variable on each side of the equation. Your goal is to get both variables on the same side and the constants on the opposite side. So it's just going to do some moving around, some rearranging, if you will. I have a 2x and an x on opposite sides of the boundary. I'm going to move this x over here. Now, that's not the only way you can do this. Let's say you saw the 1 and you want to move the 1 over here, or the negative 5 over here, or the 2x over here. There's so many ways you can do this. It does not matter. It's just, I like to have my x's on the left side and my constants on the right side. It's just a preference. Doesn't matter. So in order to move the entire x, I'm going to use additive inverses. This is a positive x, so I'm going to do minus x to undo it. 2x minus x is 1x. And then x minus x makes 0, and I'm left with negative 5. Now I just have a one-step solving problem. I just have to isolate x, which means I will move this 1 using additive inverses. And that's it. Now, like I said, you could have chosen to move something else as your first step. Let's pretend like I chose to move this 1. That makes 0, makes -6. And then I'm going to move this x to be with its friend, 0, and we get the same thing. So as long as you got -6, then you did it correctly. All right. Let's practice a little bit. Here's my boundary. I'm going to move this 2x. That makes 6x minus 8 equals 2. I'm going to move this 8. That makes 6x equals 10. Last step. Divide by 6 or multiply by 1/6. And we get 10 over 6, which reduces by 2 to be 5/3, or as a mixed fraction, 1 2/3. Either of these should be okay. Oops, I marked out my answer. There we go. Ooh, on this equation, you'll notice that on this side of the boundary, we have like terms. Since they are on the same side of the boundary, we can join them together before we get started. And then now we can solve. I'm going to actually do a different method than I normally do. I'm going to move the x's over here. And then divide as my last step, or multiply by 1/3. And we get 2. And you can do that differently. Maybe you saw it differently in your mind. -5x plus 3x plus 6 equals x. Let's say you wanted to move all the x's to the same side. That is totally fine. So these are like terms. And that would be -3x to simplify. And then we're left with nothing over here. Move the 6. And divide. Or multiply by -1/3. And we get 2. Still 2. Last one. Fractions. Yay, we love fractions. There's really two ways that you can do these. I'm going to show you, I'll show you both. So you'll notice on the fractions that we have a denominator of 2. I'm going to multiply everything by 2. Everything, even across the equal sign. So 2 times 1/2 is just 1x. 2 times 3 is just 6. 2 times 5/2 is just 5. And 2 times -8. Now I've cleared my fractions. And I can solve like normal. Move the x's. Move the constants. I guess we're going to get a fraction here. Divide. And we get 22 over 4, which reduces to 11/2, which is 5 1/2. The other way is to leave the fraction. Let's say you're fine. You're totally fine with fractions. You love them. They're wonderful. Poor fractions get hated on all the time. And let's move, like we did already, the x's to be together. This one actually turns out really nicely because -4/2 reduces. Solve for x. And divide is your last step. And we end up with our reduced answer, which is cool. But you can see that in either method, you get the same answer. So that's all for solving. I hope you enjoyed the lesson. If you have any questions, please feel free to ask me, and I would be more than happy to help you.